Hey Ellie and Callie and whoever else is listening, this is me, Mr. Lay, making my video on ionic and covalent bonding so that you can do well in the test that we're going to have on Monday. So, when you think about ionic and covalent bonding, I want you to think about a few key things. First, with ionic bondings, I want you to think about the word transfer. So I'm going to write the word transfer right here. Because in ionic bonding, the atoms that are involved in the bonding are going to transfer their electrons. And you're going to have to excuse my writing on this. It's very difficult for me to write on this like this, but it'll work out okay. So ionic bonding, you want to think about transfer. And I can't even spell right. Transfer. So ionic bonds transfer their electrons. So the favorite story I like to tell is about the wonderful world of elements. And in the world of elements, there were two kingdoms. And the two kingdoms were separated by a river. And the river flowed right through here. Here's the river. And it was a wide river that separated the two kingdoms. On one side of the kingdom, there lived a very handsome prince named Prince Sodium. And he wandered around the kingdom every day saying, "Electron, electron, I have this cursed electron. Won't someone take the electron from me?" But nobody in his kingdom would take the electron. So, at the same time, on the other side of the river, in the non-metal kingdom, there lived a beautiful princess, and her name was Princess Chlorine. And she wandered around her kingdom every day saying, "Oh, I wish I had an electron. Won't someone give me an electron?" Nobody would give her an electron. And it just so happened that one day Prince Sodium was walking down by the river saying, "Oh, I wish someone would take my electron." At the same time, Princess Chlorine was walking on her side of the river, and she heard, drifting across the river, "Won't someone take my electron?" And she said, "Someone has an electron? I want an electron!" And so she yelled out across the river, "I want an electron!" And they both dove into the river, and they started swimming towards each other. And right when they got together, Prince Sodium was about to give Princess Chlorine the electron. And they both drowned. Ionic bonding. They try to transfer their electrons. The other type of bonding is covalent. So you see the word co, and I want you to think share, because in covalent bonding, they share their electrons. So when you see the periodic table, remember my river that divided the two kingdoms. The way that the river divided the kingdoms, I'm sorry I keep going back and forth, but my pen's not working, is along the staircase. Here's my staircase. My staircase comes up and over to right there. And this is the river that separates the non-metal kingdom, which is over here on the right, non-metals, from this kingdom that's everything to the left of the staircase, which is my metal kingdom. Now there's one weird element on the periodic table, and if I continue my steps, and I come across all the way to here, and then go up, I have this one weird element, and that weird element is hydrogen. And since hydrogen is technically on the right-hand side of the staircase, hydrogen is a non-metal. It's the one weird one. It doesn't really fit anywhere nicely. So since it's technically on the right-hand side of the stairs, if I continue drawing them like I did, we say it's in the non-metal kingdom. So let's practice on determining how compounds are ionic or covalent. So here I have Na, oh, there's Prince Sodium. I keep messing up by not clicking my pen. Here is NaCl. Oh, there's Prince Sodium right there. We know he's over here from the metal kingdom. And then we have the lovely Princess Chlorine. She's over here from the non-metal kingdom. And since they're on different sides of this staircase, we know that they have to make an ionic compound. They're going to transfer electrons. Let's look at another one. O2. This 2 means that O is bonding with itself. So O is bonding with O. And both of the elements are on the right side of the staircase. So I know that this has to be covalent. Next, I have H2O. Remember, H is the oddball. Even though he's over here, he's technically a non-metal and belongs over here. So since H is bonding with O, we know that it's a non-metal plus a non-metal, so it has to be covalent. So I'm going to write a C. And that's very important. So whenever we're approaching problems on the test, I want the first question you ask yourself to be, hey, am I dealing with an ionic bond or a covalent bond? And I have a little video that we're going to watch to review ionic and covalent bonds. So let me exit out of here, and we're going to come to here. Here's the video. I think this is just absolutely too cool.
Welcome to Dogs Teaching Chemistry. Our first lesson is chemical bonding. Chemical bonds are what holds atoms together. A chemical bond is an attraction between atoms that allows the formation of a chemical substance. The electrons that participate in a chemical bond are called valence electrons. These are electrons that are found in an atom's outermost shell. Let's take a look at the types of chemical bonds that can be formed between atoms. An ionic bond is formed when one of the atoms will lose its electron to the other atom. This results in a positively charged ion, called a cation, and a negatively charged ion, called an anion. Positive and negative attract, and the result is an ionic bond. Covalent chemical bonds involve the sharing of a pair of valence electrons by two atoms. There is also what is called polar covalent bonds. These are covalent bonds in which the sharing of the electron pair is unequal. The result is a bond where the electron pair is displaced toward the more electronegative atom. Thanks for watching, and we'll see you guys next time.
All right, so back to my presentation. First, we're going to talk about ionic compounds and how we name them. And there's a few steps that you have to follow whenever you see an ionic compound. And you're going to know it's an ionic compound because you're going to see one thing from the metal kingdom and one thing from the non-metal kingdom, things from opposite sides of the staircase. And so when I look at my first example here, which is SrCl2, I see two things. Sr, which is located on the periodic table on the metal side. It's strontium, and Cl, our lovely Princess Chlorine, from the non-metal kingdom. She must be cheating on Prince Sodium. So anyways, to name this, I'm just going to label the Sr by writing what its name is off the periodic table. And Sr on the periodic table is strontium. So StrONTium, strontium. And then all I'm going to do is look at my second thing, which is Princess Chlorine, and I'm going to write chlorine. CHLORINE. Now, I'm not quite done yet, because what I have to do is I have to change Princess Chlorine's last name. Just like when you get married, girls usually change their last names. So I'm going to cross out the I and E at the end of her name, and I'm going to change her last name to IDE. So the way that I'm going to name this compound is going to become strontium chloride. I name the metal, then I name the nonmetal and change the nonmetal's name to IDE. So strontium chloride. And I'm going to always do that whenever I'm naming an ionic compound that has two capital letters. There's two capital letters, the S and the C. Now, other times I'm going to be naming ionic compounds and I'm going to say, oh, there's Prince Sodium, and here's something else. And I'm going to say, hey, there's one capital letter, two capital letters, and three capital letters. So I'm going to have a little bell going off in my head, and that bell is going to say, ding, ding, ding. You're going to have to use the chart of polyatomic ions that we gave you in class. But you're not really going to have a much more difficult time naming it, because you're just going to name the one from the metal kingdom. So Na is sodium. So I'm just going to write sodium. O D I U M. And I'm going to go to my chart of polyatomic ions. And I'm going to say, hey, is OH anywhere on that chart? And it sure is. It's hydroxide. So I'm just going to name it right off the chart. And I can't change the ending off the chart. So I'm going to write it just like it is on the chart. HYDROXIDE. And again, I apologize for my handwriting. It's the best I can do. But it's sodium hydroxide. And I don't change the ending if it's on the chart, no matter how it ends. The ending never changed. Now, I'm going to come to my next one. Let's walk through it the same way we did the first two. First, how many capital letters do we have? 1, 2, 3. So my bell's going off. It's saying ding, ding, ding. Don't just use the periodic table. Use the chart of polyatomic ions. So I'm going to look at my chart of polyatomic ions and see if any of these things are on there. And I do. I look and I see that MnO4 is on there. And when I see MnO4, I see that it's called manganate. And I'm also going to look on my periodic table and see K and see that it's potassium. So I'm going to name it just like I did before. I'm going to write potassium manganate. And potassium, if I look on the periodic table, is POT. And I'm going to abbreviate it just because I'm so bad at writing on this. That's POTTAS. So I know it's potassium. I'm just going to write the full name out, and then I'm going to copy this name right off my polyatomic ion chart, and it's manganate. MANGANATE. So that's how I name ionic compounds. Not too difficult. The next thing you're going to have to do is you're